we go towards the end of the day, and we should make we should wrap up things. And I'm pleased to present this because it's interesting. So um, as we see, as we saw with QGIS, we have this GIS system in all its functionalities. So we have a bunch of functionalities. And if you remember well, there was this in the technical specification, we had this chance to have the plugins, so to extend the functionalities of QGIS with some new codes contributed by people. So Luca developed this Mappy plugin, which extend the capabilities of the standard QGIS with something that will be very useful in planetary mapping. Not only in planetary mapping, I would say, because basically you will see that Mappy is very simple in its functionalities, but it's very important because it brings back the way we do mapping in GIS to the way that we are doing mapping on the paper. So the geologic students know that basically when you are doing the geologic survey for your examination, or you are doing photogeologic interpretation, you are using paper, you are using the translucent paper. And so Mappy basically introduced this kind of work, so makes the GIS mapping process more easier for the geologist or for the people that wants to do photo interpretation. And it replicates also something that has been available since 2017, and it has been developed by Mark Hunter from USGS. And so in ArcMap, for example, there is the geologic mapping Python toolbox, which has been used by USGS since 2017. And it has a feature which is called the build polygon tool, which is doing the same things that which Mappy introduced now in QGIS. So for example, if we are working with our colleagues with ARC, we can work in the same way using the same process, which is very interesting, and I like that very much. And I'm really happy that Luca did it, because it introduced this very natural way of mapping. So how does this photogeologic mapping process works for people that are not into geology, they doesn't have a background in geology? So the idea is this one. As you see, since this morning, we are seeing remote sensing data. And Riccardo explained very well how the contrast, how the different texture and the different albedo of images allows us to detect things on the sensor data. So this is the peculiar things of geologic mapping. While we have, for example, on the spectroscopic mapping, we are doing algorithms which processes these hyperspectral data, which produces compositional maps, for example, that is the results of an algorithm. With geologic maps, we are injecting, as Angelo said in his talk, we are injecting a lot of information, and we are also injecting our background. So we are doing interpretation. We are doing interpretation, and to do that, we are used to translucent paper, because we are detecting basically the contacts between different things. These different things are usually called unit, and Matteo introduced the units, the geologic units very well this morning. Are the units are the block, the bricks that allows to reconstruct the history, because the units are related to the same process. The units are related to the same age. And so mapping different units allows us to reconstruct the story and to tell our story, to tell the story about the area we are studying. So, of course, it needs experience, and the experienced mappers usually helps the less experienced, and so it's an experience process, but it really comes useful to get hands dirt with the real things. And so basically, using the translucent map, we start to detect what we call contacts. The contacts are basically linear features on the map which separates unit, right? So when we are doing mapping, the first thing we do is to detect contacts. The units are usually delineated by contacts. It is a result of contact. So it comes to my mind sometimes that GIS, since GIS has not been developed for geologic mapping, it has been developed for environmental analysis, for storing environmental data. So GIS doesn't know nothing about units, structures, or specific geologic stuff. So for GIS, the units are polygons. But when we are mapping, we are not mapping polygons, we are mapping contacts. And from the contacts, we define the units which are represented as polygons. So this is the idea behind mapping. So in the work of Andrea that Angelo showed, in the standards of the GIS standards, there are several layers of information, and one layer is the contact map. The contact map is one of the layers that will be part of the data of the digital geologic map. And so on the right of this slide, you see the contacts which have been mapped by hand, in this case on the translucent paper, which have been detected by me in this case over the imagery. And so the contacts at one point define the units, and the units are defined the more natural way for a human being to define the unit is to write. On one point, we write a letter sign for the unit. So in this interpretation, if I have to interpret this image, I see that there is this kind of stuff here, which is kind of part of the same unit, and there is another dark stuff here, which kind of seems on top of that unit. So the work of the planetary mapper is to map the contacts, and to sign and to mark which are the units defined by the contact. So this is the work made by hand, and it's very quick, because on a translucent paper, in 5 minutes you can do that without a computer. So you don't have to open the computer, fire up the QGIS, stay at the computer, and the computer, it can be that the software doesn't work, or maybe you have to open a project which is heavy, and so it's time consuming. With a translucent paper, in 5 minutes you do that. And the idea is that the computer should replicate that as much as possible. And so the idea is that Mappy brings this kind of workflow to your desktop. This is the idea. So let's see how does it look into GIS. So as I said, the most we bring from our natural way of doing into the GIS, the better it is. So this is the layer of contacts which have been mapped this time on the GIS. You see, I did the same thing I did with a pencil. I did it on the screen with the GIS. So I use the so-called vector file, as I said before. So we have a raster map as a base map, and we use a vector format to define the contact, because the contact is a line and can be defined by a vector of points, of linked points, right? So as you can see, the contact are not very accurate, or well, they are mapped, but not so accurately as I would say. Not because I'm messy, but because I want to map the contacts and I don't have time to take care of being so precise to finish the contact on top of that. Because I'm concentrated to define the contact, because I see that I want to see if it works, right? So I define my contacts this way in a vector layer. You will see, if you have QGIS and you will be more experienced, that you have to differentiate the type. You can differentiate the type of contact. So in this case, I have in the same layer some different linear features. So the contact which is, I define accurate because it's very clear and I can define quite precisely the contact is defined as accurate. And then in this unit, dark unit, which seems very likely to be Aeolian, to be linked to Aeolian process, in this case, I map that as approximate. So the symbology, it's different. And so we can do that in GIS. So much more like the pencil work, the paper work, we did the contact. So of course, I want also to take notes on this map, and I want to define which are the different units, because the contacts separates units, but the same units can appear in different part of the map. So for example, I call this P unit here, which appears also here and here, and I put just my point, which is another layer of information. In this case, is a point layer associated with the name of the unit, let's say. Okay, so this is my sketch work about geologic mapping of this small area, which is extracted from CTX imagery that Ricardo showed before. And this is what Mappy does. It takes the contact map, which we designed. It takes the name of the units, which we put as a point in our map, and then it processes that, producing the maps of unit. You see that the maps of unit is made of basically areas, and these areas are represented in GIS as polygons. I say, why do I have to care about merging the contact and the points to generate the polygons? It's kind of technical, because if you start from polygons, if you start defining the units as polygons, it will be a mess, because you will be so concentrated in producing polygons that when things start to be complex, maybe you start to be distracted. While with the units, with the contacts, you are concentrated on selecting the contacts without taking care too much about generating these polygons, these color polygons of the unit, which is a consequence of the contacts you have mapped. So this is what Mappy brings in. It seems very simple, but it's very powerful because it enables a workflow which is really efficient for the planetary mapper. So I wanted to make sure that this is clear to every one of us, because in this way, I think that we gain 50% of the trouble of previous GIS user in producing maps in QGIS for sure. I don't know in other system. So if you have questions, if you didn't understand something, because maybe of course it can be difficult to orient yourself without maybe a geologic background, just speak up and we can discuss, because we have some time, and I want to make sure that this Mappy concept is clear. If there is not, if there is something which is not clear, we can discuss that because afterwards we will install Mappy and use that for mapping. So let me know.
Professor, just one comment, please.
Sure.
Could we interact with the practical activities? Like while you are working, we are working to better understand what's going on and to do the practicals by ourselves.
Yes, sure. But you mean now during
Yes,
the lesson?
while you are working, if we can work also on something. It's just suggestions if they're not a possibility.
Yes. Yes, we are going to make a demo of that, though.
You will have data on your link of the activity of this afternoon. If you go in the data folder, there is a TIFF file that you can load into your GIS.
Okay, I downloaded it.
Shown how to do that, so you can try and replicate the steps.
Okay.
And in any case, all the other activity from tomorrow onward will be done in groups. So there will be an interaction with small groups, so much easier for doing things all together.
Okay, thank you.
Okay, apart this, the technical part, I mean the practical part, because using using a software, I think is matter of really pushing button. But the concept of mapping, is that clear? Is that something that we have to explain some other way or more in depth? This contact map, is the importance of this contact map relevant to you, or still the polygon is it more important than contact or something like that? Kenny, Charles. Okay, so I assume that it's okay, and if it is not, we are here this week, and me, Luca, Riccardo, the guys teaching will be more than happy to support you if we can. So what to do if the borders are not so evident? That's a good point, Tatiana, thanks. And I've tried to include that in the presentation, but we will see it in detail. This is the case, Tatiana. In this case, let's go here. You see that the contacts are very evident here, and very clear and sharp. Also here, quite sharp, but in this area, the contacts are not so sharp at all. This is, in this case, it's very easy to understand that, because the contact is is made by sands, and the process, the Aeolian process, is spreading the sand in this rough terrain. So in this case, we decided to use approximate contact just because the contact is there somewhere, and so the line is a line. So since the geologic map is symbolic, we represent something with symbolism, with symbols. So we represent that fuzziness as a proxy, or well, I decided to communicate with you, Tatiana, and the other, that contact is different from the other. So it's not accurate as the other, but because it's not sharp. So it is, in my case, I call it approximate, but it depends by the specific nomenclature you're using. Is that clear, Tatiana? Yeah, great. Okay, other points that might rise up, because I like much more that we discuss about the concept behind that on the GIS itself, to the software, because the software, I think that it would be, you have the software, you can play with that. Okay, I think that we are set up and we can go on.
We have another question about computer vision to estimate the borders. Yes, there is. There are plenty of them, actually. We go from very simple, let's say, directional filters on images that estimate the contrast between shadows and lights in order to highlight the borders. We have high pass filters that highlight the borders. If you have a DTM, you can use topographic derivatives such as slopes or curvatures and so on. And nowadays, also machine learning techniques are trained, algorithms are trained on how to recognize features or to detect, for example, craters, and try to map them effectively. So there is lots of techniques also under development nowadays.
Yeah, that's right, Ricardo. And I think that now the future will be that the path will be that we will be mapping, and also we will be mostly by hand, because at the end we are not seeking some automatic way to detect geologic units, because we decide the geologic units because we want to tell the story of the area. So the geologic map is not a detection of everything there. Is the You decide what to map because the thing that you are mapping means something in your story. So in this case, the machine learning is not very useful, but the machine learning, it will be useful if you want to map, for example, the Aeolian features over all your, like 100 square kilometers over high rise. In that case, you can use machine learning to do the work of a pure student, for example, but something that is really evident can be done by machine learning. But generally speaking, the goal of geologic mapping is not to have it automatically detected, is to delineate very well the geologic units, so that at the end of the process, your map tells a story not only to yourself, but to the others. And if your map is telling the story also to people that are kind of outside of geology, you won, basically, because the story is transferred also outside of your subject. So, and in planetary mapping is interesting because since it's very interdisciplinary, the good geologic maps are very useful to other people, to people outside of the geologic domain, let's say.
I may add something. Also, it might seem a bit, say, trivial, but the simple act of drawing a contact or discretizing units with respect to feeding a computer that is outputting of the results is different, because while you are drawing, you are thinking of the interpretation. And this reasoning is what makes the scientific process click. This seems trivial, but it's not, because also geologic maps, you will see, are very much tied to the sensitivity, to the interpretation, and also to the background of the mapper. A software will never return you a geologic map with a story, and geologic maps tell a story of events in sequence. And this is something that comes up into your mind while looking at the images, but also in the act of drawing. When you spend the time in drawing, you're not losing your time, you're actually building your interpretation while doing that. This is very important to understand.
Yeah, that's a good point, Matteo. Thanks. Thanks. That is important. I think, guys, if you bring back just this thing that Matteo said, I think that you know basically everything about geologic mapping. It doesn't mean that you are an expert, but it is the right way to do. Is the right way to go and to start understanding the process of mapping the maps and to catch the value of them. So.
Alessandro, actually, it was not me, it was Riccardo reporting something that we know, but okay. So it was Riccardo.
Ah, okay. Where is Riccardo, though? Okay. So,
I think that you can go on showing it because you have half an hour more or less now.
Yeah.
So,
okay. Charles, we will see that in the practical session, I think next days, but it is about a coordinate reference system. So let's go, though. So now that we know that this drawing of line, this line drawing that defining the contacts generates the units, and it's not the reverse, we can start using the tool. So in this case, installing Mappy. So Mappy is a QGIS plugin. So plugin, once again, extend the functionalities of QGIS. And you will find the plugin manager in QGIS under the plugin manage and install plugins. And then you have the chance to select among 633 now plugins. So it comes naturally to think, why 633? Because basically as I said before, especially if you are a scientist, if you are a researcher, you will reach a point in your research, in your work, where the software limitation cannot make you express yourself in your research activity. So the plugin fix or fill the gap which is produced by a software which has to be generic to be used by everyone. So Mappy extends the functionalities of QGIS for geologic mappers. So let's go directly into QGIS and see how to install Mappy. So this is the graphical user interface of the GIS, and you see that as we saw before, we have the main toolbar, we have the browser layers, and the main window. So the plugin manager comes from the main menu, manage and install plugins. and you have this form here. So you should have received the instruction that says that Mappy comes as a zip file. So when you fire up QGIS, you can select from official plugins. The official plugins are the more stable. And then from, you can also install plugins not via the official repository, but specifying the zip file. A zip file is an archived file, a single file, which contains the plugins, the plugin. And then you have just to select the Mappy plugin which has been sent to you. And after that, QGIS warns you that you are installing a non-trusted plugin, because of course, if someone gives you a plugin which destroys your hard disk, is not responsibility of QGIS, basically. So that's the plugin. After you say install plugin, you have the message that the plugin has been installed successfully. And then you go on plugin and you see Mappy plugin. So before you had to manage and install, and then after the installation, you have Mappy into the plugin menu. You fire up Mappy, and then you have this Mappy information that says, okay, you have this information that says that to have full potential out of Mappy, you should have geopandas.topo.json, which are modules of Python that are not required for Mappy to work for our mapping purposes. They give some extra functionalities to Mappy, but they are not required. But it's good that it is written, because maybe you would like to access these extra functionalities that maybe Luca can explain afterwards in this week. But for the basic functionalities that we saw in the slide, you don't need this kind of extension. But it is good that it is written. Okay, so we have the plugin and we can load our data. So let's see. These days you will see that QGIS will complain about coordinate reference system, because the latest version is more strict on checking that everything is all right. And if you see details of that, you see that you are doing something with the ellipsoids of not the same celestial body. So it's just a check of the software when it fires up that it sees that there is a reference system which is not the Earth. So just to make sure that things cannot weird enough, but it's not a problem. And this is the data we saw before. And then let's bring up our line work.
Ale, can I suggest you some, just to show them how to import the TIFF image, because you already have your project.
Yes. Okay. Let's say that I remove the layer, or well, that's important.
Well, can we do this with data that was a S1 folder? The data,
Yes,
it's a long name, but it's directly.
Ah, okay.
Because
So,
I think the image that you're showing is not that we have.
Okay, let's do with the image you have in your data folder. So the image with the long name is the CTX image, and then is this one. It is this one. It is called FJ02_045643 and so on. So what you can do is to take your data and bring it into QGIS. All right. Okay, so this is the data that you have. But, so, okay, so the lessons was meant to explain how Mappy works, not how to map contact, but since we are here and we have some time, we can do that. Okay, so let's do that. So basically we want to map the contacts. Of course, we don't have time to explain, to generate different kind of contacts, but we can do that. We add a layer, we create a layer, and the layer will be a virtual temporary scratch layer. The temporary scratch layer is called school contacts, school. School. The geometry type, what kind of geometry type you imagine we will use for the contact, guys? Let's pick up.
Lines.
That's right. Let's select a line. So, since we are not on the Earth, it's not suggested to select WGS84. So we have to select Mars equirectangular, basically centered on 180, which is the reference system of Mars we are using. Well, let's add a field. What does it mean? It means that we can define also the type of contact. And let's add this kind of information here. Type is text. So what does this mean? It means that when we draw, we can insert also some text or information in the draw line, right? All right. So we have contact school layer. So we create another group. It's called exercise. All right. Contact school is under exercise. Okay, so we are ready up. We are ready to map, and we go to the editing tools. And let's say that we are going to map at 1 to 25,000. So we select the right scale for mapping, which is very important to keep consistent in our mapping exercise. And we can map by selecting add line features. So I do it with the mouse, but at the Institute, I have a pretty neat toy, which is a graphic tablet with the screen down on it, which allows to draw with a pen, which is very cool. Okay. So let's say this is, how did we say, accurate create contact. Okay. So that is a contact, right? And let's define before, sorry, our mapping area, but it's not a problem because we can define also the border of our mapping exercise. That could be, let's do it like this. It's really sketchy, but it works. And this is the map boundary, right? Here we go. So let's make it more fat. Okay, so we can go on with our mapping. We are our contact mapping. Sorry. Okay, this is AB normal mapping. What do we do here? Let's say that this is the contact for now. Maybe I'm not correct. But is that right? Okay, so let's say that I'm satisfied. I'm not, but let's say that I'm satisfied now. So let's save it. So what is the other point that what is the next step now in our process of drawing? Let's speak up, guys. Give me a help.
Maybe if the
point
borders,
out.
oh, sorry.
Go ahead.
Maybe if the borders are done, we can think to write some polygons.
But since I'm a geologist, I'm the old school geologist, so I am concentrated on the contacts, and so the problem now here is that I'm concentrated on defining the units more than driving. I don't care about drawing polygons because I have more important stuff to think about. So what was the next point? Now that we draw this contact at this point, what is the next point now?
Maybe create a new layer, but with a different unit.
Yeah.
In this case, 2 units.
Let's say you're right, and basically let's mark this unit. Let's say, okay, this is this unit, this is the other, and we will see also because it's useful to do like that. So let's create another layer, add a layer, create a layer, new temporary scratch layer, and who speak up? Sasha was okay. Let's say it's a point. Unit point, and of course I don't ask you, it's a point. We use the same reference system of before, and unit name, uname, let's say uname, use symbol, let's say letter sign. And also unit name. Okay. Let's read that. So we are associating textual information to geographical information, which is peculiar to GIS, right? So you are doing high-level GIS school now. So let's do that. We can go to add the point, and then let's letter sign this one. This is, I don't know, in my experience, I would call it plateau, and I say P. I don't know if I'm right, but let's do that. Oh, plateau. Okay. And this other unit, it's called the lowland, L. Okay. Maybe it's not so representative for that, but that's just to give an idea. Okay, can save it. And just for graphic representation, let's dress it. Let's put some labels on that with the letter sign and a big 24 points bold letter sign. Boom. And we have the plane and the line. Okay. So here we go. In this way, we have been concentrated in doing this very accurate line drawing of the contacts. So even if it is not accurate, now I care about contacts. I don't want to see polygons in my geologic life now because I'm concentrated on the units which will be generated by the plugin. So let's fire up the Mappy and see if it works. So we find Mappy in the processing toolbox. The processing toolbox is this gear here. And let's find Mappy, if it is there. Here it is. So to use that is very straightforward because it's input lines, and I should suggest like to improve like input contacts, which is more professional now. Input points, it's called points. So we have contact school as an input, a units point school as an input, as a point input. And then we create a temporary layer as an output because we want to see the results.
So here with this button, we create a shapefile. We use this button to create both the contacts and the units. So we click, this window pops up. We want to save a contact shapefile. So we type contacts. And then we choose where to save. We have to click this button. And we save it, for example, here. Or we create a new folder, like Mappy. Inside Mappy, okay, contacts and save. If you don't do that, it won't create a shapefile, okay? It won't work. So you need to save or to give the path of the folder where to save the shapefile. Geometry type is line, okay? And then the reference system is the project CRS. It's always the second option. So the shapefile has the same reference system of your image. If you are all in this condition, you simply have to click OK. And then your contacts is done. Now, just to speed up the process a bit, we also create the units in the same way. So we go here in the third button, new shapefile layer. Again, we save it somewhere. We call it units. Okay. We call it units. The geometry type in this case is point. The reference system again is the second one, is project CRS. Here we need to do something more. We need to add a field to the attributes of this shapefile. It's just basically a table with different attributes that can be associated to a shapefile, and we call it, for example, geo units, because this is used to define the units. And we click here, add to field list. When you click here, the geo units will populate the attributes of the shapefile, the point shapefile. Okay. We click OK again. And so we have these two files, contacts and units. So very quickly, I will start editing the contacts. Okay, with this button here, I tried to replicate what Ale was doing. So to mark this beautiful lobe. So with the left button, you add nodes to your vector. Okay, and with the right click, you close your line. Okay, you can leave it empty, or you can type I don't know, 1. It's the same. You click OK. Let me change color. So by double clicking it, you can change color to your lines. We make it, for example, red, so we can see it. Okay, we can add more. So we want to encompass all of it. So we just simply mark again this unit here. I'm not pretending to be too much correct or straightforward, but just to give you the idea. Then we cross intersect this, which is the best option in my opinion. So just cross and then click OK again. Then we can create the small, for example, these small units, which is something that is below this dark lobe. So we can start marking this crater, for example, here. We can mark, we can also zoom in, of course. So we can mark other things. I'm just doing it very roughly and very quickly. You can add, but the more nodes and vertices you add to your vector file, the more precise it is. Or there are other functions to draw, like with the graphic table. Okay, so this is it. And we would, for example, all the surroundings, we can create a large, just a large unit like this, like a square, which can be like the surrounding planes. Okay, just like that. Okay, so we can stop editing, and by clicking again here, your pencil icon here disappears. You save it. Okay, you have all your contacts. I can make it a bit larger, for example, so you can see it better. And now we have this dark unit, which is on top of this bedrock. Okay, and this bedrock is also inside this depression of this unit. We also have an impact crater here. We can mark it. Why not? We simply need to digitize it again, like that. Okay, we just save it again. And so we use the units point shapefile to create our legend and to populate the units in order to close our geologic map. We start editing with the pencil button again. It appears here. And then with this button on the top, just next to the pencil icon, you click and your cursor becomes like a crosshair. Okay. And you can click and assign the units. For example, I want this lobe here to be a single geologic unit. So I click here. I can leave this ID empty, but I need to populate the GeoUnits field in this pop-up window. And we call it, for example, dark lobe. It's okay. It's just a test. Okay, the point is here. I can place it here, wherever, sorry. Then we have, for example, the crater. So we click inside the crater and we call it impact crater. Okay, then we have all the bedrock. Okay, all around. Let's pretend it's all the same thing. So it's bedrock. Again, bedrock. But very nicely, the bedrock is also outcropping here in these small holes inside this lobate flow. So we click again here and simply call it again bedrock, but maybe in the correct way, bedrock. Here, again here, bedrock. This is probably an impact crater, so we can click inside this and call it crater, no, impact crater, sorry. You have to be consistent with the names you give. For example, impact craters must be called in the same way. If not, Mappy will create different legend elements according to the names. So impact craters must be impact craters. Low bed flows must be always low bed flows. The more variety you create inside this field, the more populated will be the legend of your map. We click OK, and we save the edits. Click here, save edits. Now, if we are lucky, we go to Mappy here, just in this menu here. Click on this arrow, on this other arrow, map construction. So we can add the input lines, my contacts file. Input points is units. Create temporary layer. This is used to extend lines. It means that if you didn't cross two lines, like in this case here on the top, but the lines are a bit one detached from the other, you can create a tolerance distance, and then Mappy will close the polygon for you. But you have to be very careful on how you use it, because you can create some funny things. So in line of principle, try to reach this solution where you don't snap, but just cross a bit the lines. And then you run. You see, it gives an error, but it's no problem. So we have this. This is our map. This is not very beautiful because it has the same color, because we need to then classify according to the geologic units. So we go here on the newly created layer. We can toggle off these two. And you see all the intersections now disappear, and the polygons are all nicely closed. We simply double click on the constructed map. You go on the third option, it's symbology. We do not want a single symbol, but we want a categorized map. So we go to categorized, and we categorize according to which value? To the geo units that we populated while we were placing the points inside our regions. And then we simply click classify. You see, we'll have a classified map with bedrock, dark lobe, and impact craters. We click apply, and now we have our map. The impact crater here, for example, did not show up because probably I didn't close very well the impact crater. So how to do and how to check? We simply turn on the contacts. We go and check, and you see here, I did not close my line. Okay, so in this case, I need to use the tolerance button. Do you see this? Yes. So how to do that? We can simply discard this first constructed map is our first interpretation. We just run Mappy again. Input lines, then input points. We extend lines, let's say, I don't know, 50 meters, maybe less. Let's go for 20. Oops, 20. We then run again. You see, now I have my polygon closed. So I have also my impact crater. We double click on the newly constructed map. You see, it created a new one. We categorize by using the geo units value. We classify, and we apply. We can also adjust transparency if you want by going here just below to legend. You have this opacity slider that you can use. You click here and you do apply, and then you can also adjust the transparency of your map. And so this is a nicely created geologic map with Mappy, just mapping the contacts and placing the units according to our interpretation afterwards. As far as you refine your interpretation, you can just adjust your contacts or your units. You can cancel the units, you can add more units, and you can create new maps with Mappy. And as soon as you're happy with it, since this is saved in the RAM, it's not saved into your disk now, you simply, I don't know, export, save as, or you can map construction, when you create your map with Mappy, simply save it here. So not in a temporary layer, but you can save to file, like dataset or to geopackage. And then so it gets saved into your hard drive, like that. Mappy dataset. GeoPackage is like a container that contains all your vector files in one place. So you click that, you name it Mappy demo, and then we want to do this again. We run it, and then we can categorize it as we did before. So symbology, categorize, GeoUnits, classify, apply. So you see, it's a very straightforward process, and you will use it a lot of times during this week. It's simply a matter to map contacts in a way that seems reasonable to you and to assign the units. And of course, you can adjust the units, what's on top and what's below, according to the sequence of events you're finding in your image. But this is the process, and it should be quite easy to replicate in the end. Okay.
Okay. Thank you, Ricardo. We probably are running out of time, but I have seen several questions. Most of them are related to the fastness that you have used for making this demonstration. In any case, it was needed because of the time. You have not to be afraid, because tomorrow and the day afterward, we will use this tool several times, so you will get used to do it. Tomorrow in particular, we will do a moon mapping in a very simple area. So we will go through all these points that has been raised. So someone was asking how I can erase a wrong line. You should select it and then delete it. There will be several times that we will have to do it in the next days. So if you want, Ricardo, you can show it. And you were very fast on showing the opacity even. So someone is asking for that. But
I was answering them, but now I will show you. So it's
yes, it's much easier and faster.
Okay.
And but do not worry. We will go through all these points even slowly and in different groups already tomorrow during the moon mapping.
So the opacity slider is very nice. You double click. We can do this with this. Okay, so this is completely opaque. We go here on the left on the table of contents. Double click. This layer properties window opens. It's the same window where you categorize your symbology. Okay, you have different options all on top of each other. Okay, if you scroll down towards the end, you have the legend button here. Okay, you click on legend. You can change the text, for example, on your legend here. If you toggle this on, you can change your text. But more importantly, here below, you have available widgets, and one of them is opacity slider. Okay, so double click here. This pop-up window opens. Scroll down towards the end. You go to legend. Then on the bottom part, click on opacity slider. Then with this arrow, you move this to the used widgets. Simply click with this arrow pointing to the right. So you have this one also here. Now this is going to be used into your table of contents here. You click apply, and now the slider appears below your layer. Then you can click OK, and with the slider you can adjust the transparency.
Eric.
Yes.
Okay. Can I show the guys the problem that was into the, if they're running that kind of problem, I found the solution there. So if any one of you finds that kind of problems of not building from Mappy, I found that Mappy was telling us that the spatial index were not constructed because we did produce the temporary layer. So if you fall into that kind of problem, the solution is to go to the layer, and on the second row of the layer information you have geometry, and then you can update the spatial the spatial index there. You can create spatial index, which was the problem there. After that creation of spatial index successful, you can fire up the Mappy, and now it works. So it's important that the spatial index is built into the files. So even if you don't know what spatial index is a kind of ordering, internal ordering for the map. You have, if you find this kind of problem, is the spatial index. Afterwards, it will work, and then you can do the tricks that is showed by you saw from Riccardo on the constructed map. Okay, so that's it. And then the last thing that I wanted to show you is that this way of doing is that if at a certain point you want to change the aspect of this map, it will be very useful. It is very useful because at one point you would, for example, like to introduce Aeolian features which are present here. So without having to deal with the polygons here, because if you go editing these polygons, you see that you have to move these nodes, and it will be like very difficult to make all the polygons coherent one with each other. You just have to get rid of the layer and concentrate on mapping. So on the contact map, the only thing you have to do is to map your contacts, concentrate on mapping your contacts. Yeah, I'm not precise here, but and then you add your D unit. And then you save it. And you should be able to produce the map with a new unit. That is important because you concentrate on contact mapping and not on generating units. Then, of course, you can categorize. You can categorize on the letter sign. Riccardo showed you that you can, for example, add opacity. And that's it. So basically, you are concentrating on producing a map from your contacts. That is the main idea. Okay, so for mappings, I think is all that I wanted to tell. And if there are 10 minutes still. And so if there are questions, if you want to see symbology or whatever, let's speak up.
So I think actually that we ran a little bit out of time because it was supposed to end at 6 p.m.
I see.
So,
half past.
But it's not a problem, I think, for an hour. And I would stop here, and our appointment will be tomorrow at 9 in the morning for the moon mapping. So many of these things will be explored again with your own instructor. So the moon mapping program foresee a subdivision in 2 groups. So it could be more easier if you have some problems or you are a little bit slower. So hope this first day, it was quite intense, but interesting in my opinion. Hope it was interesting also for you. And so have a good dinner, and for the people that I would say that are in the evening today, and see you tomorrow.